Good morning, class. So today we're looking at trigonometry. As promised in the last lesson, we're going to divide this first exercise up into two. So now we're going to look at example for exercise 2 on page 95. And this is it covers of exercise 2 number 4 and 5. Okay. So looking at the first sum, we are told in these worked examples you will expand the compound angle formula. Just a reminder, what is the compound angle formula? We know that cos of alpha plus beta can be written as cos alpha cos beta minus sin alpha sin beta, and cos alpha minus beta can be written as cos alpha cos beta plus sin alpha sin beta, and sin alpha plus beta can be written as sin alpha cos beta plus cos alpha sin beta, while sin alpha minus beta can be written as sin alpha cos beta minus cos alpha sin beta. How we remember it? We say cos is CC with the opposite sign, while sine's ratio is the same. So sine's ratio are different with the same sign. Okay, so one is the ratios are the same together, whilst here the signs are the same, whilst the ratios are opposite or different. So let's look at number 4. The question says, show that sine of a plus b multiplied by sine of a minus b is equal to sine squared a minus sine squared b. But if I look at that there, that actually plays into number 3 as well. Not so. This is actually the example for number 3, but I gave it to you for homework. And you guys didn't complain. It's either one of two things: you knew what to do, or what didn't you do? The homework, yes. Okay. At the end of the day, it's like your education series, isn't it? Alright. So people, where do we start? Where do we start with this question? Where do we start? This is an identity. Not so. Example on page 94. No? So where do we start? Since it's identity, we're going to do the left hand side or right hand side story. Not so. So you're either going to take the left hand side and make it equal to the right hand side, or you might take the right hand side and make it equal to the left hand side. So which side do you think you're going to work with? The left hand side. As expansion is easier than the reduction. Okay. So sine of a plus b can be written as, or sine of alpha plus beta. Sine of alpha plus beta can be written as sine alpha cos beta. Sine alpha cos beta. Same sign. Cos alpha sin beta. Not so. And this is what sine alpha plus beta is equal to. Why am I putting that in the bracket? Because it must be multiplied by. So let's expand sine alpha minus beta. What will it be? Sine alpha cos beta minus sine beta cos alpha. Or cos alpha sine beta is the same thing. You all agree with that? Okay. So what do I notice here? The conjugate pairs. Not so? This will result in a difference of 2 squares. Not so? What can I do? I can multiply the first and the last. Okay. So what is sine a cos b multiplied by sine a cos b? Sine squared a cos squared b minus cos squared a sine squared b, or sine squared b cos squared a. But is this equal to the right hand side? No. So what do we have to do here? Check what do we have. We need sine squared A, so I'm not going to change that. That one I'll change. And we have sine squared B, so I'll keep that and change cos squared A. You see that, people? So we know that sine squared B plus cos squared B is equal to 1. Hi, boss. Yeah? Yeah?
Alles 100%?
Yeah.
Danke meneer.
No problem, boss. Afwan. So what is cos squared B equal to? 1 minus sine squared B. So I'll replace that with sine squared B. Sine squared B can be written as, sine squared B is going to be 1 minus cos squared B. Okay. So let's go with that. So there's going to be sine squared A times cos squared B is 1 minus sine squared B minus sine squared B into 1 minus sine squared B. Did I make a mistake now? You seem to be okay. So what do we do now? We read the brackets, not so. So sine squared A times 1, sine squared A. Sine squared A multiplied by negative sine squared B. It's negative sine squared A, sine squared B. Negative sine squared B multiplied by 1. Negative sine squared B minus plus. It's supposed to have been an A and you made a mistake. Not so. Because I cos squared A plus sine squared A is 1. So cos squared A can be written as 1 minus sine squared A. That's what I'm thinking, why? But okay, no mistake there. That will be plus sine squared A, sine squared B. You all agree with that? See any confusion this far? So what we do? We add like terms. Now sine squared A, sine squared B is the same as sine squared A, sine squared B. Not so. So what happens? Cancel. So what do we left with? Sine squared A minus sine squared B, which is also equal to that. Okay. Any confusion there? Let's look at number 5. Number 5, you are told find the value of sine 75 without the use of a calculator. People, if they say without the use of a calculator, what comes to mind? Special angles. So we're going to need special angles along the line. Okay. Now, if you're looking at sine of 75, sine of 75 can be broken up into 2 special angles, not so? Which 2 special angles? You all say, What are the special angles? 45, 60, and 30. There we go, 30 and 45. So it will be sine 30 degrees plus 45. Or sine 45 plus 30. But what do you see now? Double angle. don't see a double. You see a compound angle. But what is a compound angle? It's an angle that is made of two different angles. Okay, that's a compound angle. Later on, if we talk about double angles, it will be a part that, or an angle that is made up of two of the same angle. Okay, so the compound angle is an angle that is made up of two different angles. But besides that, what we see here, sine alpha plus beta. Not so, sine alpha plus beta. So, with sine alpha plus beta, sine alpha plus beta can be written as sine alpha cos beta plus cos alpha sine beta. So let's write that. What will it be? Sine alpha, what is my alpha angle here? 30. Cos beta, which is 45, plus sine 45 cos 30. Or cos 30 sine 45, the same. So with that, what do we do? We construct special angle. This is going to be 30, so it's 1, 2, root 3. And the other one is going to be 45. This is the isosceles line. Okay. Now what? Now we know sine of 30 is equal to, what is sine of 30? 1 over 2 times cos 45. Cos is adjacent of hypotenuse is 1 over root 2 plus sine 45, opposite of hypotenuse is 1 over root 2 times cos 30. Cos is, what does cos stand for? Adjacent of hypotenuse. So it's root 3 over. So from here it becomes 1 over 2 root 2 plus root 3 over 2 root 2. Can be written as 1 plus root 3 over 2 root 2. And of course, if you want to rationalize the denominator, we're going to multiply that by root 2 over 2, root 2 over root 2. You don't have to do this. So the question did not ask to rationalize the denominator, which is then going to give me root 2 plus root 6 over 4. And that is, when you put this in a calculator, that's what you will get. Sine 75, root 6 plus root 2 over 4. You guys understand? But as I said, they wouldn't require you to rationalize the denominator. Okay. Something like this probably worth 4 marks. 4 or 3 marks. I think 4. But just think about it. What other angles could they have put in here if they wanted you to have two double angles, two compound angles, or to form a compound angle? It's going to be 45 plus 30. We use that. No? Also 45 plus 60, which is 105. What is 60 minus 45? 25. 15. 30 or 45 minus 30, 15. What else would I ask you? Of course, the reduction now. If they ask you sine of 95, let's give it written firstly as sine of 180 minus 75, or 90 plus 15 is also, then it's going to be second quadrant, so it's going to be sine of 75. Then we go again. Sine of 75 can be written as sine of 30 plus 45, and so on and so on. People, you guys understand? Is there any confusion? Right. So with that, you should be able to do number 3, 4, and 5. Okay, but you guys should have done number 3, the odd numbers already. So the homework for Monday, of course, is going to be 3 even, 4 odd, and 5 odd. Okay. I'm just going to touch on 5.1 because I don't want you to now be confused now. Just to refresh your memory, I'm going to do 5.1 for you. Okay. This is out of exercise 2 on page 95. We are told here, if sine of alpha is equal to 4 over 5. A is acute angle, which means to say less than 90. Then we are told that cos of beta is equal to negative 12 over 13, where beta is greater than 0 but less than 180. The question says evaluate or determine or simplify cos beta minus alpha. Okay, that is what we must evaluate. What's the question? Yeah, evaluate or determine would be another word for evaluate. Okay. So when we start here, firstly, what do you notice? We have two different angles, not so. So what does that mean? We're going to have two different diagrams. Not so. Now, when you look at sine of alpha, sine is positive. So which quadrant does that take you in? All station to clear one. Which quadrant is sine positive? 1 and 2. But we are told that A is acute. So what does that mean? It's quadrant 1. So which quadrant do we draw in? Quadrant 1. Okay, so there's 90. So sine stands for opposite over hypotenuse. Isn't it time? At the end of the lesson, we did it. The values are going on. Okay. So what does sine stand for? Opposite over hypotenuse. So it's 4 over 5. So what do? I apply Pythagoras and I get 3. If I go on the side here, this tells me that cos is negative. In which quadrant is cos negative? 2 and 3. But beta is greater than 0 but less than 180. Which quadrants are they referring to then? 1 and 2. So I'm drawing in quadrant 2. What does cos stand for? Adjacent over hypotenuse, so that's 12 and 13. Where does the negative belong? To the 12. Why? Because it's on the negative part of your x-axis. Can you see that? Now apply Pythagoras and get an answer of 5. Is that 5 positive or negative? Positive. Why? Positive part of your y-axis. Can you see that, people? So in other words, this was alpha here, and this was your reference angle, or your angle beta. These are your reference angle. So now let's just answer the question. The question says, what is cos of beta minus alpha? Cos of beta minus alpha. What do we know about the cos identity? It's going to be cos. So cos beta, cos alpha, same opposite sign. Sine beta, sine alpha. There we go, cos of beta. Cos is adjacent over hypotenuse. So it's negative 12 over 13 multiplied by. Now you see, now they talk about alpha here. So I must go with the alpha triangle. Can you see? So it's going to be 3 over 5 plus sine of beta. Sine is opposite of hypotenuse, so it's 5 over 13 multiplied by cos of alpha. Alpha angle again. It's going to be 3 over 5. Sorry? Sine is? Sorry, what did I say, Jason? Opposite, sine is opposite of hypotenuse, so it's 4 over 5. So that's going to give you negative 36 over 13 is going to be 65 plus 20 over 65. Which gives me negative 16 over 65. Just check if that's correct. Is it correct? Huh? Don't just say yes. Can I go down in history for the person who doesn't know how to do trig? Correct. Okay, now I'm feeling better. People, enjoy the weekend and the rest of your day. Good morning, class. Don't forget that. It's important for Monday's lesson.